Okay, so our next section in our trig is 1.3 and it's trigonometric functions. So again, we're dealing with our trig. Okay, and so we have kind of a simple point. We're saying let x, y be a point other than the origin on the terminal side of an angle theta. And again, remember, theta is our symbol right there, in standard position. And the 6 trig functions of theta are going to follow. So what we mean by this first is let's draw a picture. So if I have my y-axis and my x-axis, and I draw, say, a ray coming out of here, right? So here's my lovely ray. What I'm going to notice is that what I can do is that this is going to be a point, right? And then this is my x, y. And if I notice is that I can create a right triangle, which is wonderful. Here's my x, and here's my y. And what we're going to have is we're going to have this lovely r right here is actually what we're going to be trying to, kind of our hypotenuse. And our angle is, again, here's our initial side. This is our terminal side. So this would be our lovely theta, okay? And so everything kind of falls in the fact of this kind of triangle. And so our 6 trig functions are as followed. Our first one is the sine of theta, right? So again, we don't know what that degree is. It will always be your y over your r, okay? So again, y over your hypotenuse, things like that. Your cosine of theta will always be x over your r. So again, x over your r, and then tangent of theta is y over your x, right? And remember, tangent is kind of like your slope. Things to remember about this. Notice your ray will never be 0, right? You can never have a distance of 0. Here we want to make sure that we understand that we might have an x equal to 0, so we want to make sure that x can never equal 0. And if it does, then it becomes undefined, right? So tangent sometimes is undefined. Now, sine has a reciprocal, right? And that is cosecant of theta, r over y. Again, we're saying y cannot equal 0. And then this is our secant of theta. And this is r over x. Again, x cannot equal 0. And then cotangent of theta, which will be x over y. And again, y cannot equal 0. So we have 4 scenarios where we potentially could have a denominator of 0. Again, I just want to make sure that everyone understands the words. So sine is abbreviation for this word, sine. Do not pronounce it as sin, right? Cosine, right? COS is the abbreviation, cosine. Tan is the abbreviation for tangent, right? Cosecant, right? And then secant. And then secant is spelled like this. And then cot or cotangent. So you would think that sine and cosine would go together. You would think that cosecant and secant would go together. And obviously tangent and cotangent do go together because we see that those are reciprocals of each other, right? But in reality, these two actually go together. And then these two actually go together. Okay? So things to think about is how can we actually find out x, y, and r and things like that? Well, we see that it's a right triangle, so we can always use the Pythagorean theorem. X squared plus y squared is equal to r squared. Things to remember is that r will never be negative. You're always talking about the hypotenuse and the distance. So our r is actually always going to be a positive. We can potentially get a negative for x. We can potentially get a negative in for y. So we do want to pay attention to what quadrant we're dealing with. Okay, so let's see how these all kind of shake out. So let's try our first example. So we'll call this example number 1. So we're going to find all 6 trig functions of theta in standard position that passes through the point 512. So that's our problem. Okay, so the first thing I'm going to do is 512, right? So if I'm going to graph that, I know that 512 is in this quadrant, right? It's positive and positive. So if I draw my ugly looking ray, let's draw this again. Let's just draw a ray. Boop. There's my ray. And there's my 5, 12 right there. So what do I know? I know that this distance is my y, so that'll be my 12, and this distance is my 5 right there, and then this is my theta. Again, it's an unknown value. So what we don't know is we don't know r. So let's find r first, because we actually want to make sure that I can plug in values for all of these numbers, because eventually we'll be finding our theta. Okay, so I'm going to use my Pythagorean theorem, so 5 squared, plus 12 squared is equal to r squared. So 25 plus 144, which gives me 169 is equal to r squared. So r is equal to 13. That's the hard part. Okay, the rest is easy. So first thing I'm going to do is discover my sine of theta. So remember, sine of theta is your y over your r. So y is 12, r is 13. So 12, 13. Cosine is next. So cosine, remember, is the x over your r. So your x is 5, and then your r is 13. Tangent is slope. So remember, that'll be your y over your x. So 12 over 5. And then remember, all of these are your reciprocals. So the reciprocal of sine is cosecant. Reciprocal of cosine is secant. So cosecant of theta is 13 over 12. The reciprocal of cosine is secant, 13 over 5. And then cotangent of theta, 5 over 12. We want to make sure that we leave all of our answers as fractions. Don't simplify it. Leave it as a fraction. It'll make life a lot easier for you. All right. So let's go ahead and try another example. So call this example 2. So same thing. So 6 trig through the point, -3, -4. So go ahead, try pausing the video right now and see if you can come up with your 6 trig. All right, if you're coming back from pausing the video, I'm going to go ahead and draw my picture. You don't have to necessarily draw a picture, but I find it good and helpful. So my point, -3, -4 should probably be in the third quadrant. So again, I'm going to create a squiggly right triangle. So right triangle, boop, 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 boop. So again, this value right here is my theta. Okay, so -3 is my x, so -3 right here, -4 right there. So I'm going to go ahead and solve for my r. So 9 plus 16 is 25. So r must equal 5. And if hopefully you notice that this was a 3, 4, 5 triangle, but if not, no worries. All right, last but not least, sine of theta. So sine of theta is your y. So -4 over 5. Again, don't forget the symbol because sine by itself is nothing. Cosine is your x, so -3 over 5. Right, tangent is next. So it'll be -4 over -3, which can be simplified down to 4/3. All right, and then cosecant should be 5 over -4, secant 5 over -3, and then cotangent, I already know the negatives are going to cancel out, so it should be 3 over 4. So again, we can find it through point and everything like that. All right, let's go ahead and try one more different type of problem. So this time, what we're going to do is, we're going to find all 6 trig functions. And then this time is with the given information, with given info. So I give you this. X has to be greater than or equal to 0. And I give you this. X plus 2y is equal to 0. So what information did I actually give you? Well, I gave you a line. All right, so right here is your line. And what I did right here is I restricted the domain. So domain is right there. All right, so let's go ahead and try to plot this information. So the first thing I'm going to do is I'm going to solve this one. So 2y is equal to x. negative x, y is equal to negative 1/2 x. Okay, so now I got so I know that I'm starting at my origin, which we always do, and then I know I'm going to go down 1 and then over 2. So I'll actually be at the point 2 comma negative 1 at that point, or I can go up 1. But notice that I said x's are greater than 0, so I knew that I was going in this direction. If I said x's were less than or equal to 0, I know that I'd be going in this direction. So all of a sudden I've created my my line. So here's my arrow. There's my ray, and again I can create my triangle. So this will be 2 and negative 1. And at that point we can continue. So let's go ahead. So 2 squared plus negative 1 squared equal to r squared. So 4 plus 1 is 5. This time we're going to get a radical. Okay, we want to make sure, make a little note right here, we want to rationalize all fractions, right, that have a radical in the denominator. All right, so we want to take us back to some algebra skills. All right, so let's first talk about the sine of theta. So sine of theta, again, y, so negative 1 over the radical of 5. All right, how do we rationalize it? I'm going to multiply radical 5 over radical 5, so multiply of 1, which gives me negative root 5 over radical of 25, which is going to give you radical 5 over 5. So that would be my sine. Do the same thing for cosine, so I'm going to kind of skip this middle step right here. So it'll be 2 over root 5. So again, I'm going to multiply and multiply. So I'm going to get 2 root 5 over 5. Tangent is easy. Tangent is just your negative 1 over 2. When I find my reciprocal for sine and cosine, I don't necessarily want to reciprocate over here. I'm going to do it on this one. So cosecant of theta will be a root 5 over negative 1, which is just negative root 5. Secant of theta will be a root 5 over 2. Can't simplify that. And then cotangent of theta will be 2 over negative 1. All right, which again gives you negative 2. Again, I want you guys to note for tangent, right there. So tangent, bam, bam, right? Tangent of theta is the same as the slope of the line. So again, notice that tangent of theta is the same as that lovely slope right there. Okay, so again, once we have one thing, then we kind of know what we're doing. We actually already have our y and our x. We don't actually need to create this this video, or not video, create this ray.